Again, we'll just finish the loopings, and then the others are just like more on, to enhance your programming skills. So we will not discuss those anymore, okay? All right, so this is where we have stopped last meeting, if I'm correct. Tama ba? As
Yes,
far,
sir.
far as I remember, we were able to finish the letter A, wherein the answer is 5,050. So let's try. Where is that one? Assignment. I think it's this one. Okay, so just wait a second. Hindi yata ito yun. Okay, let me just find that specific. Parang ito yun eh. Assignment. Assignment loop. Oh yeah. So it is this one. So the summation from 1 to 100. So all we need to just keep on adding, just keep on counting, and then just keep on adding that one on our variable sum. So parang nai-stack lang dito yung mga numbers na nabibilang natin. Alright, so that's it for the letter A. So the answer for this one is 5,050. And then for the letter B, so this one is also ranging from 1 to 100, so we don't need to change this one anymore. However, this one now is requiring us to add the even numbers only. Okay, I is divisible by 2. So for us to be able to do that one, okay, so we can, make some tricks like uh, we will start with 2 and then we'll keep on incrementing by 2. Okay, so we can also use the, where is that one again? I forget the name of that one, but it's the opposite of division. Okay, I'll just show that one to you guys so that you'll have an idea how to answer that one the other way around. So it's in here on the module 7. Division. Hmm. Yeah, right here. Modulus. So you can also use this one because this will only get the whole number. Okay. So yeah, but for this one is applicable. So you can start with 2 and then and with 100, and it's incrementing by 2. So for this one, I guess it's 2,000 plus. So let's search summation even number. So the sum of even consecutive integers from 1 to 100 is, where is that one? In order for us to verify, I think the result is 2550. Sum of add is 25. Sum of even is 25. Let's check. Yeah. For the even, it's 2,550. And then for the odd number, okay, so if we're going to change that 1 into odd number, so let's start with 1 and it's incrementing by 2. So 1357 until 99. This will give us 2,500, I guess. So yeah, 2,500. Okay, so for the summation 1 to 100, it's 5,050. For the even number, it's 2,550, I guess. Where is that one again? Yeah, 2,550 and then 25 for the odd number. Alright, so that's how you do it for the odd and even. And for the letter C, so it's I squared, so just square the number from 1 to 10. So all we need to do is range is 1 from 1 to 10, and it's incrementing by 1. And then the sum right here will be squared. Oops. Sum squared. Oh, I see. Okay. So counter 1 to 10. If it's less than 10, sum counter is 1. Ah, Alright, so for the summation of 1 to 10, so 1 squared, 2 squared, plus 3 squared is 385. So the one that we need to square right here is the counter, since this is the one that keeps on incrementing. Okay, so initially, of course, it's 1. Counter is 1. And then it will become 2, okay? And then it will become 3, and so on and so forth. So every time that, it will loop, that one will be squared from time to time, okay? And then it will keep on adding on the sum variable right here, and then will be displayed on our message box. So yeah, that's it for the letter C. And then for the letter D, so all we need to do is do as the same with this one. So it's ranging from 1 to 5. So initial number is 1, final value is 5. And then for the counter, so it's 1 over 2i. So just divide this 1 over 2 times, oops, this is a mistake. 1 over 2 times counter. Okay, because our I here is the number. So for this one, the result is 6. Okay, so whatever is your counter, so 1 half times 1, so that's still 1 half. And then 1 half times 2, it's like 1/4. So just keep on doing that one until you reach the value 5. Just wait a second. This one is at the bottom, so it should be 1 over counter. Okay, not just times counter, because if it's times counter, it's on the numerator. But for this one, it's on the denominator. Okay, so my bad on that one. So we have to fix this formula. 1 half times 1 over counter. Save. So we should get a decimal. Oops, why is it 0? 1 half times 1 over 1 is 1 half, plus 1 half times 1/4 is 1/8. Mm, Ah, I see. So our expression or our formula is actually correct, but the declaration of the sum and counter is incorrect. So this one should be single so that it can display a decimal. Okay. So that's the reason. Yeah, thank you for that one. So I saw your chat, Mr. Ramji. So this will give us a decimal of 0 point something, which is, or 1 point something, 1.14167. Okay, so that's the result or the summation from 1 to 5 if you have this kind of formula. All right, so that's it for this assignment. So are we clear so far regarding with this one, A, B, C, and D? Okay, great. All right. So for the next one, we have here the exercise number 9. So make a program that computes distance a body falls in feet per second for the first 5 seconds of free fall as given by the equation. So we have this formula right here for the acceleration. I mean, this is acceleration. So wait, S is equal to 1 half A is acceleration, and then T is time in seconds. My bad. S is the distance. Okay, distance traveled in feet. Okay, so we have here a sample output like we assume that we have 1 to 5 seconds only. Okay, so first 5 seconds, and then we have to calculate the distance that's being covered using this formula. Okay, so for the first second we have 16, 2 seconds we have 64. So yeah, let's try this one. So we have this code right here. So all you need to do is copy this one and then try to analyze what's happening right here. Like this is the title, this is the value below that, this is the formula for the distance, this is the initial value, the final value, and then this is where you show the results on the data grid view. Okay, so take note when we say results, we're talking about rows. When we say titles, okay, we're talking about columns. So those are the difference, okay? And then the first one, of course, is the time, and then followed by the distance, okay? Wherein we formatted this one. So again, if it's F, it's in a fixed value, wherein we are only getting the two decimals, okay? So even though it doesn't really have a decimal, so it will give us a decimal 0.00. And then it's incrementing by 1, okay? Since we wanted to get the 1 to 5, okay? So this is exercise number 9. So let me just get my own code, number 9. So yeah, same code. And then just two components, a label and then a list box. I mean, data grid view, not a list box. So if we're going to calculate, so in my case, it's 1 to 10, okay? Yeah, it's 1 to 10, not 1 to 5, but you can change that one, of course. And then here's the equivalent distance traveled. Okay, so I guess this one is, quite easy, especially if we have already learned this one in physics. So S is the distance traveled in feet. So yeah, that's it for this example. Did you guys get this one so far? So if ever that you have a question, so feel free to raise your hand or just speak right away. Okay, so we can uh, make a remedy of your or to your problem. Okay. All right. So that's it for this example. Let's now proceed to exercise number 10. So this one is a little bit much more complicated. So the x and y coordinates as function of time of a projectile fired with an initial velocity v at an angle at theta with respect to the ground is given by this formula right here. Okay, so for the uh, x formula, we have v times time times cosine times the angle. And then for the y, we have here the v times time times sine times theta minus 1 half gt squared. Okay, so using this formula as the right code that allows the user to input for the initial velocity. Okay, so let's say 350 meter per seconds for now. at an angle, say, let's say 25 degrees. So display a table of x, distance traveled. So this is the formula for the x, and y, which is for the height. So this is the formula for the height. Values for a projectile fired at time interval 0 to the total time of flight. So that is t is equal to times v times sine times theta divided by g. Okay, so this is the formula for time. Okay, and second speed increment of 1/2 second. So it's incrementing by zero point 0.5. So remember to convert the region measure. So here's the expected output or the sample output if we have these inputs right here. So we have 350 and then 25, and then we will let the computer to solve for the time of flight, okay, using this formula right here. So here's the time, okay, from 0 to 6. Why is it 0 to 6? Okay. So in here, uh, we are not the one who's going to set the time, so it will fall, okay, to, let's say, 0 seconds. So initially, of course, it's still flying, and then eventually it will reach its peak height, okay, and then it will fall, okay, and then once uh, it already it's traveling at a zero distance or at zero time, and that's the time that it will stop looping. Okay, so for the code of this one, so we have this and this one. Okay, so for this one we have declared 1 2 3 4 5 6 variables. Okay, so for this one we have singles, and then g is a default value. Okay, so I think this is a force value 9.80 in acceleration. Mm, where is that one? If I cannot find it, you can search this one later on. But for the letter G, okay, this is a fixed value, okay, coming from this one right here. So yeah, you have to equate that one to 9.8665 or 9.81. Okay, and then we only have two inputs, okay, the velocity and then the angle right here, and then we have here the titles. Okay, so of course we have to clear that one every time we are clicking the button, and we have here the titles, the time, first column, distance, and then the height. Okay, so that's it for this line of code. And then we have here the t flight, okay, the time of flight right here. So 2 times po times mat that sign, which came from this one right here. 2 times v times mat that sign times angle, okay, radians angle. So in here, all you need to do is convert this 1 into radians, and then divided by g is a fixed value 9.8665. And then for the text box 3, okay, where is this one? 1, 2, 3. Okay, so this is just the formula. So it's being passed on the T flight. So it's not being shown on this one yet. So whatever is the result of this T flight right here will be displayed on our text box 3, which is this one. All right. And it's also being formatted into two decimals, okay, and 2. So you can use f also fix or 0.00. 0.00 is for whole number, okay, so you can use n2 or f, okay, so either of those two to show two decimals. And then we have here an initial time of 0, okay, and then until it's now less than or equal to t flight. So once that one becomes false, then that's the time that it will stop looping. Okay. So we have here the formula for the distance, which is the x, and then we have here the formula for the h, which is the y. So those two came from here. So let's base it on this formula right here. And then for the values, okay, so we are showing them in a data grid view. So rows for the values that add. So the first column is time, followed by the distance, followed by the height, okay, and it's incrementing by 0.5, okay, which came from this one right here, 1/2 second. And right here, so we have this t is equal to t flight, wherein we're going to solve again, okay, for the distance and then the height, okay, and then we'll show them again on the data grid view one rows that add. So it's quite the same with this one. So you will know later on what's the purpose of this final result right here. So this will basically show us the zero result, okay, after this t flight right here. So let me show this one. Oops, is it still this one? No, not this one. Exercise number 10, I guess. Number 10. Yeah. Okay, so just wait a second. So this is the code for this one. So everything came from the PDF. So all you need to do is copy and paste that one, and then change the namings of your data grid view, since in there it's DG1. So to remove that error, it should be the name of your components right here. So if you have changed the name of your data grid view, then whatever is the name of your data grid view right here should be the same with your name on your code right here. Okay, so let's test this one. So 350 and then 35, 350 and then 25, 25. Okay, compute. So initially, of course, it's 0, and then it haven't traveled yet, so 0 distance and then 0 height. But at 0.5 seconds, it's now traveling at 158.660 feet, and then at a height of 72.73. Okay, and then until it will reach the peak. So the peak is peak. So yeah, the peak value is at exactly 15 seconds, okay? 1115.50. Okay, that's the highest point that it was able to reach, okay? And then it will now fall down to 1114, 1111, 1105, 1097 until it will fall on ground and then reach 0, okay? So this last line right here, okay? This last line right here is the one that is being displayed by this code right here. Oops, this one right here. Okay, so if I will remove this one, it will not be able to display this 0 height right here. Okay, so that's the purpose of this additional formula for this one. Okay, so we have to recompute again for the final value, which is the 0 height. So yeah, is it complicated?
Yes, sir.
Yeah, it's really true complicated. So uh, I highly encourage you guys to do this one on your own and then try to experiment, try to analyze what's happening on every line of code. Okay, because I'm just discussing this one briefly, just the overview, and then I'll let you guys analyze afterwards. Okay, so again, we have to convert this one into radians, so that is why we have to multiply this one into mat.pi divided by 180. So in here, we're just saying radians, but this radians right here is mat.pi divided by 180. So you have to multiply that one right here. Okay, so that's it for exercise number 10. And for the exercise number 11, so given different values, assume all are integers listed in the list box, determine the sum of all the values. So you can actually do this one, like you have an array, let's say an array. So this is a list of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can actually add all of those. You can get this summation, all of those, and then place it on a text box or a label. Okay. So the code for that one is this one. So dim total. So we have the total for the summation. And then counter, okay, for us to be able to fetch the values inside of that list box. So for fetching, we have this formula right here. So for counter is equal to 0 to list box 1 that items that count minus 1, okay. So what this do is this will fetch everything inside of our list box, okay. And then once it's done fetching, so it will keep on adding, okay, to this variable total, okay. So 1 2 3 initially, and then plus 4 5 6, it will now go to total, plus 7 8 9, it will now go again to total until it reach the value of 0, okay, which is meaning it cannot retrieve any more data, and then it will be displayed on our text box one.text. So let me just show this one, number 11. So the same code, let me just show the result. So one more thing, so as you guys can see right here, whatever is the total, it's being converted to a string, okay. So we can also do that one, okay. So let's say this is the number that I have inside of my list box. So if I click compute, it will give me a sum is 2,479. Okay. So of course you can edit the values inside of the collection, okay, of that list box. So let's say you can add more. Let's say negative 500, and then click OK, then compute, and then it will give us a value of 1,979. Okay. Well, anyway, this is another example showing on how to retrieve data or get the data inside of a list box, and then what are the things that we can do. Okay, we can get the summation. Maybe we can even display each lines, okay, using a message box. And for these exercises, okay, let's just answer this 1 to 12, and then we're done. Okay, so let's see if we can finish this one in 7 minutes. So exercises, tell how many times does each of the following loops iterate, and what is the final value of the variable x in each case. So for the number one, okay, how many times will this iterate, or how many times this will loop? Anyone?
26, sir.
26. Okay, very good. That's correct. And then what is the final value of x?
30.
Okay, very good. So yeah, that's how easy it is to answer. So just practice answering this one, because this will be part of your final exam. Okay. Maybe there are 15 questions of this, asking you how many times it will iterate, and then what is the final value of this one. Okay. How about number two? So let's use a notepad so that the others will see. Number two. Anyone from the class? How many times number two will iterate or loop? And then what is the final value of x? So for the number one, okay, it will loop 26 times, and the final value is 30. How about number two? So coming from Mr. Ramji, I said 9. What about the others?
8, sir.
8. So let's see what is the correct answer. So we'll start with 10. So it's incrementing by 5. So 10, 15, 20, 25, 30, 35, 40, 45, and then 50. So let's count this on. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 9 is correct for Mr. Ramji. Okay. So malayo yata yung 3. So this will loop 9 times, and then the final value is what? What is the final value of
50.
x?
50, sir.
50. Okay, very good. How about number 3? How many times it will loop? So we started with 60, and it's now decrementing. And take note, we have here a until loop, okay? So the condition must be false for it to work.
3 times, sir.
So let's see. So initial value is 60. So it's decrementing by 10, 60, 50. And then once it reaches 40, okay, so it will not loop anymore because 40 is equal to 40. So it's true already. So it will not be able to reach 40. So 60 and 50 only, okay? So this will loop 2 times only. And then the final value is 50, of course, okay? So it's really quite tricky. So that's the reason why I'm writing down, okay? Para mas kitang-kita ko kung tama ba or hindi. How about number 4? So coming from Mr. Remji, it's 1. Okay. So if you guys are going to take a look on this one, so we have until. So again, this must be false for this to work. But then if you're going to take a look on this one, initially 100, okay, 100, oops, where is that one? 100 is already greater than 70, okay, which is already true. So in this case, this will never iterate, okay? And then the final value is unknown, okay? So we have uh, some something like this also, all right? So this will never do. All right, that's it for the 1 to 4. So we now only have 2 minutes left. So maybe we will have a part three. I mean part two. Okay, but maybe just 5 minutes or 5 minutes or 5 to 10 minutes maybe. Okay, but anyway, so let's try to finish number 5. Anyone? How many times number 5 will loop? Anyone from the class?
7, sir.
7? Okay.
5, sir.
So, okay, let's see. So we've started with 15. So it's incrementing by 5, 20, 25, and then 30. So if you guys are going to take a look in this one, we have this exit while, meaning if your x is already greater or equal to 30, then it will exit the loop already. Okay, so in this case, it already reached 30. Okay, so it will now close the loop. So in reality, it will never reach 30. Okay, because it will close at that value already. So it will not be able to show that value 30. So that is why it will only loop 3 times, and then the final value is 25. Okay, 3 times, and then the final value is 25. Okay, so yeah, that's it for now, and then we'll just finish the rest on part 2. So we still have 6 more items, 6, 7, up to 12. Okay, so goodbye for now, and then see you guys later. Okay, so just join right away because this will just be a few more items. Mabilis na lang to.